Okay, so in the last videos we looked at the basic graph of sine and cosine, and now we need to know what happens when we have variations on those graphs. So as a little bit of a review, you should remember this from your algebra days. If you have your basic graph is f of x, this is for any graph. If you were to multiply by a number out front, let's say you put a number out front of the function like this. So remember what that does is it's a stretch or compress on the graph, and it's going to change the height of the graph. So stretch or compress in the y direction. Okay, so if it's bigger than 1, it's going to be a stretch. If it's less than 1, it's going to be a compress. So like at half out front would chop the height in half, and 2 out front would make it twice as tall. If we put the number on the inside like this, okay, if it's multiplying on the inside, that's going to be a stretch or compress in the x direction. And remember, x is usually, when it's on the inside, it's opposite what we'd expect. We'll go on and look at that one. Just like before in algebra, you probably didn't have to memorize what that did to a graph. And again, because it's going to end up affecting the period that we looked at before, again, you don't really have to memorize what it's going to do, because we're going to talk about how to figure that out exactly. All right, and then if we have our function and we add or subtract a number on the outside of the function, okay, that's a shift up by c or down by c. Okay, so if we do f of x plus c, that's going to shift us up by c units, and f of x minus c is going to shift us down by 3 units. And if we put that on the inside, like that, that's going to be a shift left or right by c. Okay, so remember, it's opposite what you'd expect when it's on the inside. So if it's positive, it's going to shift left, and if it's negative, it's going to shift right. Okay, and we'll look at examples of these, but these are just some of the basic graphing transformations. Actually, we have one more. If you put a negative out front, remember that that's a reflection. And it's going to be a reflection, it changes the signs on the y values, so it's going to be a reflection around the x-axis. And if you put a negative on the inside, let's see if we can squeeze this in here, that's going to be a reflection around the y-axis. Okay, and as it turns out, we can actually put all of these together, but we're going to take them one by one, at least for right now. And then we'll see what it looks like all together. Okay, so we're going to switch over to a graphing app here because the pictures look a whole lot better than when I draw them. So we're starting off with the sine function. Okay, it looks like this. The graph's a little bit more spread out than what I had before, so it looks a little bit more like a gradual S shape than what I had, and that just depends on how you space these pi over 4 increments. So theirs is a little bit more spaced out than mine. And we can see that we go between -1 and +1. We talked about that in class, and we talked about it in the last video. And we've got that S shape, and remember that our period is 0 to 2 pi, so we go from 0 to 2 pi, and then it's going to keep repeating in both directions with that same shape. Okay, so this is the sine graph that we already looked at. Now let's look at what happens when we put numbers out front of it. So we talked about this. If you put a number out in front of it, that's going to stretch or compress in the y direction. So let's turn that one on. And now we see the blue is 2 sine x. Now look at it. It didn't change our intercepts because it's not stretching or compressing in the x direction. What it did do is it raised our height to 2. So we had a local maximum right here. Now our local maximum is up here at 2. So you see it stretches it like that. Okay, and then here, the green one now is 3 sine x. We can see it's the same picture, but now we're going all the way from 0 to 3, 0 to -3, 0 to 3, 0 to -3, and our period is still 0 to 2 pi. Okay, so that's what it looks like when we put a number out front. And this number that's out front, this height, positive and negative, that is called our amplitude. Let's look at one that's less than 1. Okay, so this one's, let me change the color on this. Let's make that one orange. Okay, so the orange one you can see here, that's 1/2. So 1/2 out front is going to make the height smaller. Okay, so there's our orange with the 1/2. All right, so this number out front here is going to change the height of the graph. Okay, so let's turn those off. Go back to the regular sine graph. Okay, so there's our regular sine graph. Now what happens if we put a negative out front? Okay, remember a negative out front is going to flip it around the y-axis. So you should be able to see that the purple is the same picture, but it's the mirror image around the y-axis. Okay, so how do we put these together? If we want to do -2 sine x, this one right here, -2 sine x, you say, okay, I think of 2 sine x. That's my sine graph going from 0 to 2, and then 0 to -2. And the negative out front is going to flip it. So I'm going to go 0 to -2 first. So -2, 0, +2, 0. So it just flips the order that you're going in. Okay, so if we had -3 sine x, you would think of this graph, and then you would flip it around the y-axis. So we go 0, -3, 0, +3, and so on. Okay, so that's what the number out front does to the graph. Okay, back to our basic sine graph. All right, now let's look at what happens when we multiply a number on the inside. So remember, that's going to be a stretch or compress in the x direction. And when it's on the inside, it's opposite what you'd expect. So you see this sine 2x right here. Okay, if it was on the outside, it would make us bigger, but on the inside, it does the opposite. Okay, and it makes us a compression in the x direction. All right, now look at, here, let's take this out for just a second. Okay, now look at the picture here. We get one complete S rotation now from 0 to pi. We changed our period here because we compressed it. Okay, multiplying by a factor of 2 is going to compress us by half. So now our period is half of what it used to be. Instead of having a period of 0 to 2 pi, now we have a period of 0 to pi. But look, our amplitude has not changed. We still go from -1 to 1, and we still start at 0, 0. Okay, and then from there, because there's no shift, that's why we're at 0, 0. And then from there, we have twice as many x-intercepts because we had that compression. Okay, so again, there's sine versus sine 2x. Okay, so the red is our regular graph, and the green now is the 2x. So what happens if we do sine 4x? This is going to look a little bit busy here. Come on, there we go. Sine 4x. So let's take the green one out of there so we can see this. Okay, now look at how compressed our little S shape here is. Okay, and it keeps repeating, and it keeps repeating, and it keeps repeating. So now what is our period? Our period goes from 0 to pi over 2. We have a very small period, and we can see that it's a very small graph there before it starts repeating. Okay, look at how many we can fit. The red one is our original sine graph, 0 to 2 pi. How many periods can we fit inside of that now? 1, 2, 3, 4. We now have 4 periods inside what used to be 1 period, and that's not a coincidence. That's from the 4 right here. Okay, so that gives you a visual idea of what happens when we put a number on the inside. Now let's put a number less than 1 on the inside. So if it's doing the opposite, we would expect a number less than 1 to make it smaller, but it actually makes it bigger. So look at that. Look at the black line. Okay, we're actually going to have to move this over to see 1 period. We'll barely can even fit it on the screen. Look at the black line. We're going 0 to 2 pi, and now to 4 pi. Our period is now 0 to 4 pi. It's huge. Okay, so when you put a fraction on the inside, it does the opposite of what you think it's going to be. It's going to make it bigger. All right, but our amplitude is still -1 to +1. The numbers on the inside do not change that.